Hello, and welcome to another one of my recordings. Through this recording, I'm going to cover Chapter 5 of your textbook, which essentially discusses mathematical functions, characters, and strings. So let's go ahead and start. There are some objectives. Of course, you have these slides, so you could go through them. But essentially, what we want to talk about is talk about numbers, characters, and strings. And I'll also tell you a few items that we will skip because some of the materials sort of beyond the scope of this class. But so let's go ahead and start. The first thing we're going to start is with mathematical functions. Java gives you a whole bunch of math functions in a class called math that allows you to take advantage of these functions so you don't have to write any extra code. The math class contains a couple of constants like pi and e, which is the exponential value, and pi is the constant 3.1415. And it allows you to do trig functions, exponential functions. It allows you to do rounding and create random numbers. So, for example, if I go in here, you look at, by the way, I will provide this this file in as a part of this recording. So you'll notice I have a system.out.println math.py and math.e. So if I compile this and then I'll run it, I have a whole bunch of other stuff. But notice pi is 3.14 and e is actually 2.718. So I should really go in and change this to e. Okay, so that's how we use the constants. Your book has a whole bunch of examples. Some of the trig functions are kind of noteworthy because the way the sine and cosine and all of these other functions that you may never ever use, they require a value in radians. So if you want to find the sine of 45 degrees, if you use sine of 45, this doesn't give you the correct answer. Instead, you have to take that 45 and convert it to essentially to degrees by multiplying by pi over 180. Now, those of you who've done math recently, you'll know that pi is also 180 degrees. So 180 divided by 4 is 45. So you'll notice that this provides the incorrect answer, but both of these provide the correct answers. So if I just ran this, you'll notice that the 0.85 is incorrect, but 0.707 is the correct answer. So if you want to do any kind of trig functions, you have to take your angle, whatever the angle you want, and multiply it by math.pi over 180 to get the correct result. Of course, since I'm here, math.sqrt will return the square root of the number. And there are, like I said, tons of mathematical functions that Java provides for you. As with anything else, what's important is to know the usage of these functions or methods. You have to know the name of the method, you have to know what type of value to give it, and you have to know what it does, essentially what it gives you back in return. If I go in here again, so you can read all of this on your own, and the best thing to do, by the way, is just try these methods or functions on your own and make sure that the results agree with what these methods do. Rounding, we can actually use a bunch of functions like ceil and floor and rint or round to actually manipulate our numbers. The ceil function is kind of interesting. It always rounds your numbers up to the nearest integer. So if I say ceil of 2.8, it's going to give you 3 because it's just going to round up. If I do floor with 2.8, it's going to round it down, which is going to round it to 2. If I say rint with 2.8, it's going to round it to the nearest integer. Well, you have to ask yourself, well, what is the nearest integer to 2.8? Well, that's going to be 3. Round of float of x, again, round of any number. Essentially, this is what we traditionally do if the If the number is 0.5 and above, it will be rounded up. Otherwise, it will be rounded down. So what I have in this example is a bunch of essentially, I'll scroll this down. Notice I have the little line numbers that you must have seen in your math classes. And so this is the 0, everything to the right is positive, everything to the left is negative. So CEAL of 2.8, remember again, you go back to the definition of CEAL and it says it rounds it up to the nearest integer. So really it takes the number to the right. So 2.8, I will say, is right around there. So CEAL of 2.8 is going to be 3. CEAL of 2.2 is still going to be 3 because it's going to round it up. And then CEAL of minus 2.2, now remember 2.2 or negative 2.2 is right around here. So when it rounds up, it should round it up to negative 2. So let's just go ahead and run this. So the first one, so CEAL of 2.8 is 3, CEAL of 2.2 is still 3, and CEAL of negative 2.2 will be negative 2. So for negative numbers is a little bit trickier because the negative numbers work opposite the way positive numbers work. So instead of me going through all of these, make sure you go through these examples once you get it, and make sure you satisfy yourself as the output based on these definitions. Again, the negative numbers might be a little tricky, so you'll let me know if you have any questions. Okay, so your book has a whole bunch of examples also. Max A and B, min A and B, they're kind of obvious. They're going to give you the maximum of 2 parameters. This will give you a minimum. ABS will give you absolute value. Now, random is something that you probably want to use a lot in programs. And the way random works is that it gives you a pseudo-random or random number between 0 and 1. Notice that 1 is not actually included, so it actually goes from 0 to anything less than 1. It'll never be a number such as 1. So if I go here and notice I did create a random number, it's 0.77, and then of course if I run this again, I'm going to go ahead and close this because we have a whole bunch of other examples here. So if I run this again and notice 0.77195, try it one more time, 0.56. So obviously, because it's random, essentially it's using the system's clock to create a seed for these numbers. So every time you run the code, you're going to get a different random number. So that's what the random does, and that's the usage, math.random. Now sometimes what we want to do is we want to create a random number between 2 numbers. Let's say I want to generate random test scores. Well, I know they have to go from 0 to 100. So this is a real nice formula. This says essentially you take your lowest number. In this case, the lowest number is 0. And convert, this is a way to change the type of whatever follows to, in this case, int. It says take the random number, multiply it by high minus low plus 1. So in this case, 100 minus 0 plus 1 is 101. Remember, the reason for that is that random never gives us 1, so we have to accommodate for that. Now, what if I wanted to throw a dice? Well, may as well change that. So throwing a dice was going to be between 1 and 6. So the random number would be 1 plus math.random times 6. Well, why 6? Because 6 minus 1 plus 1 will give you 6. So as you can see, you can generate a number between 20 and 50. The same idea, the same simple formula. So we will use the random function, so these slides, and of course your book also gives you some detailed information. Okay, character data type. Essentially, a character data type is anything that stores only one character. So when you say char letter equals to A, we're actually storing the single character A. In this case, we're storing the number 4. Again, all Java cares about is one single character. It doesn't matter whether this is a question mark or exclamation point or whatever. Java also allows for the use of Unicode, which Unicode system, which we won't actually cover in this class. So you could safely ignore the coverage of Unicode material in your textbook. But if you have any questions, you let me know. And a couple of things about, I guess, or observations about the character is that because characters or character data type are so similar to integers as far as Java is concerned, because we actually look at its ASCII representation, we can actually increment or decrement our characters by 1. So in this case, character A, and then you say plus CH, that's going to give you the letter B, because A plus 1 would be essentially the letter B, which is next right after A. So this is kind of neat because you can make some good simplifications just based on that. So Unicode format, we can ignore that. So the ASCII code, you don't really have to know any of these ASCII codes because Java already is going to take care of it for you. But it doesn't hurt to know the major ones. Digits 0 to 9 correspond to decimal 48 to 57, or Unicode 30 to 39, and so on. The only thing you can see from here is that the capital letters have a smaller value than lowercase letters. And that comes in handy when you start sorting data. So let's say if you had a whole bunch of names that you wanted to order, then the case of those strings matter. Okay, now there are some special sequences for special or escape sequences that the ones that you really want to know about is /t, which gives you a tab in your output. /n will give you a line feed, and \\/ will give you essentially a literal backslash or a backslash code will give you a literal double code. So for example, I have right here an example. If I say \n hello, it's going to actually display \n followed by hello. If I say \n hello, is now going to treat the \n as a new line, so it's going to go to the next line and it's going to print hello. So let's just see that quickly. I'm just going to notice \n hello, the \n literally appeared, and then because it was a print line, it goes to the next line, and then on this one, hello, well actually hello here is due to this \n. Now, since I'm here, let's take a look at this example. We said char letter is A, and then we printed A right there. Then we say numchar or whatever is 4, and we printed numchar, that's 4. Now notice this one, it says print line letter ++. Now because of the order of operation, association of these operators, what you're going to do is you're going to first print A, and then increment the letter to capital B. So that's why it displays A, and then letter right here as a result of this line is going to be B. When we say ++ letter, is actually increments it by 1, so and then displays it, so that's C. And then letter, of course, is C, so it'll display C. So just keep in mind that you can do essentially increment operators on characters. Okay, so ASCII character set, again, all it is ASCII is just a convention that maps all of our characters on the keyboard to some numbers that then programs can use. Okay, now again, like I said, int I equals to A is perfectly fine because what it does is that it will save I into I, the ASCII code for A. And char C equals to 97 is the same as typecasting an integer with a character. Okay, so this is nice because you can take a character and actually check to see if the character is bigger than A and less than Z. Well, this is nice because what's happening is that we can actually decide whether a character is uppercase just by this simple range condition, because all you're checking is the ASCII equivalent or ASCII numbers equivalent to these characters. If you want to check to see if something is lowercase, then it has to be bigger than A and less than Z. Something to be numeric has to be bigger than 0 and less than 9. So you see, you can ask the user for a character and then check to see if it's uppercase or lowercase, or if it's even numeric or not. Now the character class, which is a superclass, again, we'll talk about classes and object-oriented programming in much more detail in Chapter 9. But just like we've talked about, the scanner class and the character class or the string class, these are special classes. And the only nice thing about these classes is that they give us additional functionality. So notice the character class has a function called isDigit. Well, that tells you that you can check this. You can check to see if a character is a digit. Now, by the way, there's a typo in your book also. This should be is letter or digit. You can check to see if something is lowercase, uppercase, etc. So when you get a chance, go through the examples that I have in here with some more that kind of exercises all of these things. So I've commented it out here. Of course, you go in and uncomment it to run it. Okay. So that's it. So let's just quickly, since we're here, I just want to double check and notice that now we talked about this a bit later in this chapter, but in order to read a integer, a character from the keyboard, what we can do is we could read the line and then convert it or look at the first character or the character at position 0. So when I run this code, I'm going to compile it. So when I run this code right here, it's going to ask me enter a digit or a letter. So it's obviously asking me for a single letter. Of course, I could type anything I want. All it cares about is that first character. So if I put in 1, it's going to come back and says, well, you know your digits and letters because I said if character dot is letter or digit, then you know your digits. Notice if I run this again, and if I put in a question mark, it's not going to tell me anything about the success message here. So I guess I could have put an else in here and say, hey, I asked for a digit or a letter. So again, this is how you can compare. You can compare or find out if or essentially validate user entries. Now here it says enter any string you like. And notice we use a function called, or a method called nextLine. Now nextLine is going to read everything I type. So if I do hello there, it's just going to read the entire string. Now next, later we talk about this function called next, which stops right as soon as it hits that white space character. So it will only read hello. So what do you think is going to happen here? The string is hello there. The string.char as 0 is definitely going to be h. String.length is going to be the length of this, whatever that is. Remember, this also counts because even spaces count. So if I count, there's 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, actually 11. And str to uppercase will convert that to uppercase. So the length is h, 11, and hello there. And then it says hello there, okay, bye, because I use a function called concat. And concat essentially appends or concatenates two strings. Here it says enter your full name. So if I put in Joe Smith, what do you think it's going to read for str right here? Well, remember it's going to stop right there, so it's just going to read Joe. So when I press enter, notice it says welcome Joe, and it didn't read Smith. So if you wanted to say welcome Joe Smith, you should have used the next line in here. And then it says welcome Joe. But now notice what happened here. I have enter your first string, and I'm accepting input from the user. But notice what happened. It just skipped it. It didn't even let me type in the value for my first string. The reason is that next reads just up to that first white space character. So that white space character is still hanging in inside this buffer or this stream of characters. So this next line will consume that value, and S1 is actually becomes really a white space. So, and notice then it goes to enter your second string. So if you want to avoid that, anytime you see something like this, what you want to do is you want to go in here and code just a blank input.nextLine. That way it will just throw away the leftover carriage return or the leftover white space. That way, you know, your program works the way it's supposed to. So same thing. We're going to run it again. I'm going to put 2, and it says, okay, that's good. Enter any string you like. So I'm going to say hello there. And then it says full name. I'll say Joe Smith. Obviously, it's just going to read Joe. But notice now it waited for me to enter my first string. So here, if I type in Joe as my first string, and for my second string, I'm going to do Bill. Well, actually, I'll do Joe again. Now, you might expect, because I'm using the equal operator for equality, you might say that, well, Joe is equal to Joe, so it's going to say the two strings using the equal are the same. But it's not going to work because the equal operator cannot be used to compare two strings. Because what it's doing is actually comparing the address of these variables. So notice when I press enter, instead of getting this, which makes sense to get, you're not going to get that. But look at S1 dot equals S2. Now dot equals is a method within the string, so essentially all it does, it checks to see if this equals to this. So when I press enter, this is going to be false, so I'm not going to display this, but here I will display it. Notice as right here, the two strings are the same. It just didn't run this at all because this condition will always be false. Now, we also have a function called compare to. So it says S1 compared to S2. And now compare to, if we go back to our slides, you'll see that compare to gives us, I'm just going to go over a little bit faster, or maybe not. Well, let's see if it tells you. Yeah, compare to S1, it returns an integer greater than 0, equal to 0, or less than 0. Essentially, indicating if string 1 is equal to string 2, string 1 appears before string 2, or string 1 appears after string 2. And by that, I mean in alphabetical order. So that's something that you kind of have to read up and ask questions if you're not sure. But these examples should help. So for example, what do you think happens if S1 and S2 are going to be the same thing? So let's just run this thing. And I'm going to do that. It says, I'm just going to press 1, enter your full name. Okay, enter your first string. I'm going to do ABC. Enter your second string, also ABC. Well, ABC compared to ABC, they're exactly the same, so you're going to get compare equal to 0, right? Compare equals to 0. Now let's go back and run this again. Again, 1, 2, I just want to bypass these. First string, let's do Adams, and then let's do Clinton. Okay, now what you're doing, or what Java is doing, is comparing the first character to the first character of these two strings. If it can make a decision, if they're not the same, then it'll make that decision. If they are the same, it'll just move on to the next character and so on. So A and C. So if you look at your alphabet, A appears before C. In other words, you could say Adams is smaller than Clinton, or A is smaller than C. So notice what happens when I press enter. It's going to give me a negative number because Adams is smaller than Clinton, or it appears in a phone book before Clinton. And it gives you -2, and the -2 is really an offset between A and C. So, you know, if A has a value of 1 and C has a value of 3, it's really giving you the difference between these two numbers. So, which isn't too bad because that could have some applications to find out what the offset is. Okay, so we could do that. Now, since I'm here, I suppose I'm not going to go through that. Now, substring 3. What does substring 3 do? Or substring 0, comma 2 does? Remember, the whole idea here is for you to be able to look at the definition of these methods and essentially identify or find out what they do. So length returns the number of characters. Well, that's obvious. If I move over here to char at 0 is this. Length is 15, char at 14 is that. Trim, to lowercase to uppercase, they're obvious. And I just want to bypass those. And let's see, I want to get to substring. Okay, so it says substring begin index to end index. So let's go back to my program. I have substring 0, 2. It means look at the string, start at 0, and go up to this character minus 1. So if I put in hello as my input, so I'm just going to write this here, HELLO. So this is the 0th position. This is the first position, 2, 3, and so on. So it's going to start at 0 and go up to 1. So what I expect to get is HE if my input was hello. So let's double check that. Let me close these. Not that it matters. So Control 1. Make any changes? Probably not. Control 2. Okay, so 1, 2. Now remember it says, what is it looking at? S1. Okay. S1, I have to be careful because I don't have good prompts here. So enter 2 strings. Okay, 1, 2. I put 2, so it's going to give me an error message because 2 doesn't have 2 characters. Okay, so that again, we'll get to an error recovery, by the way, in this class in a few chapters from now. So let's run this again. I'll be more careful this time. When it says enter your first string, I'm going to do hello. And it's going to give me a second string, say bye. So notice it gave me right there, what is it? L-O, oh no, sorry, it's he right there. So your first string is, or the first 2 characters is HE because of that. Now, substring with 3, notice it starts at position 3 and goes all the way to the end. So hello, 0, 1, 2, 3, which is this L, and then O is the last 2. You can also convert strings to numbers. So we could we use this function, essentially this operation, integer.parseInt, will convert a given string to integer. Double, so if you wanted to convert to double, this would be double.parseDouble with a capital D. Okay, so let's go back. So again, this slide is again, your book also covers this stuff in detail, but this slide is pretty good because what we talk about when we get to arrays in a few chapters, you'll see that strings essentially are an array of characters. The first position is 0, and it goes all the way to the length minus 1 because we started at 0. Okay, so what do you think index of CH does? Well, it returns the index of the first occurrence of this character in a given string. So if I say index of tick mark H in hello, it's going to give me 0, and so on. So again, you have to play with these and just run, essentially write a program that exercises all of these functions so you can get better at finding out what they do. Okay, so here's a good example. I'll let you guys look at that. Guessing birthdays, those are some good examples. Formatting output. Printf function, for some of you who may be, I guess, familiar with the C language, you may remember the use of printf. And the nice thing about system.out.printf is that you identify the format that you want a number or an item to be displayed. So if I go in here, notice it says double D, it says enter any floating point number, and then it grabs the number. So if I go back in here, Well, this is the other one. You can find that. Okay, it says enter any floating point number. So if I put in 4.8976, 4.8976, what this says, it says it's going to print number equals percent 10.2, meaning it's going to give you 10 spots, and then it's going to right justify. So from the right side, it's going to give you 2 digits after the decimal point, and it's going to round, by the way. So 4.8976 should be 4.90. So let's just press enter, just double check that. Notice it says 4.90. And notice how it's right justified. So it skips, essentially gives you a field length of 10, and then writes the numbers this way, essentially. So you've got 1, 2, 3, 4, and then 6 spaces. Now, if I just said %F and didn't specify the number of digits after the decimal point, then it'll just give me the whole number. Okay, so this is a nice way to display formatted numbers. And if you look at this example here, this is nice because what they're saying is that count is 5 and amount is 45.46. So notice from left to right, it's going to say count is %D, meaning I'm going to give a format specifier. D is for decimal integers, and amount is %F, and F is for floating point numbers, comma. So note the use of comma in printfs. Remember in system.out.print or print line, we don't use commas, we use the plus symbol. Here you have to be careful and use the comma delimiter. So what's going to happen is this count is %D, so it's going to go and look at the variable count, which is 5. And amount is amount with %F, which is 45.56. And now remember, if you say %.2F, it's just going to give you 45.56. If you say 0.1F, it's going to be 45.6 because it's going to round it up. So they have a nice program under this format demo. I'm hoping that you all already know how to get access to these sample files. Okay, so there, looks like I'm done. It's about 30 minutes, and maybe I ran over a few minutes over the usual 30 minutes. But what I want you to take out of this chapter essentially is know what type of functions are available within the math function. Of course, we can always use the Java documentation to tell us everything about the functions and the constants that Java gives us. And what's most important in any use of any of the methods is always finding if you know how to decipher the description of a method. If you know how to decipher this, that means you can write your code using any of the predefined functions. So, for instance, starts with prefix. It returns true if this string starts with a specified prefix. So I could say S1 dot starts with open parentheses and then quotation, double quote, ABC. That way, if I have data that starts with the word ABC, then I can extract or I can look at that data. Same thing with all of these other ones because what they have is essentially functions. So welcome.to lowercase is going to convert this to all lowercase and so on. One thing I just wanted to make sure you understand also is that if you add strings to strings, you get another string. But notice here, if you add string to a number, it automatically converts this to a string. So you're not going to get an error message because of that. Even a character can be added, and then this automatically converted to a string and then added to this other string. Okay, I'm going to go ahead and stop here. I hope this was helpful, and goodbye till another recording.